Hello, this video is for textbook lesson of chapter 2, lesson 3. It is titled Solve Two-Step and Multi-Step Equations. Our objective for this lesson is to solve equations in one variable that contain more than one operation. So why learn this? Well, equations containing more than one operation can model real-world situations such as the cost of a music club membership. Alex belongs to a music club. In this club, students can buy a student discount card for $19.95. This card allows them to buy CDs for $3.95 each. After 1 year, Alex has spent $63.40. To find the number of CDs, and we'll use C to represent the number of CDs, that Alex bought, you can solve an equation. So here's the equation here that they've provided for you, where in red we have the cost of the CDs, 3.95 times C, the cost of the discount card, 19.95, and then in green we have the total cost of 63.40. So let's go ahead and look at the next slide here, and notice that this equation contains multiplication and addition. So we see the multiplication here between the 3.95 and C, and then we also have the addition where we're adding the value of 19.95 to the product of 3.95 times C. Equations that contain more than one operation require more than one step to solve. That's why we call them either two-step equations or multi-step equations. Identify the operations in the equation and the order in which they are applied to the variable. Then use inverse operations and work backward to undo them one at a time. So here we have 3.95 times C plus 19.95 equals 63.40. Well, order of operations say you have to multiply before you add. So if we were going to be working this problem out, we would have to first multiply the 3.95 times C and then add the 19.95. Well, the operations that we used were that first C is multiplied by 3.95 and then 19.95 was added, correct? So now we're going to work in the reverse order and use inverse operations. So if we multiplied first and then added, well, now we're going to take care of the adding part than the multiplying part, but we're going to use inverse operations. So if we need to do what is step 2 becomes step 1, and the inverse operation to adding is subtracting, first we're going to subtract 19.95 from both sides of the equation, and then once we've done that, we can then divide both sides by 3.95. Now, another way to look at this, and one that I kind of prefer, now I'm going to go ahead and rewrite this problem. 3.95 times C plus 19.95 equals 63.40. And I'm going to pretty much do the same thing, only I want to kind of focus on it a little bit differently. We need to isolate the variable C, right? We're trying to find out what C is, so we want to get it all by itself, so we want to isolate it, get it all by itself. And before we can get to it, we have to deal with the 3.95 that's tied to it through multiplication. But first, we also have the addition of the 19.95. So if we're going to work our way down to this variable of C, we need to first get rid of whatever might be there that's tied by addition or subtraction, and then we'll deal with that. So we have a 19.95 here. It is positive, so we're going to subtract 19.95 from each side. What we do to one side, we are going to do to the other as well. And yes, I'm going to go ahead and grab my calculator for this one and do 63.4, and we're going to subtract from that 19.95. And that's going to give me a result of 43.45. And over here on the left, the 1995s canceled each other, and we're left with 3.95. We still have the variable C. Now we're at a one-step equation. And like we've done in one-step equations before, the 3.95 is tied to the variable c through multiplication. The opposite operation is division. Remember, every fraction is a division problem. We're going to divide by the very number we wish to get rid of. And what we do to one side, we are going to do to the other as well. And the 3.95 is going to cancel each other, leaving us with c, and 43.44, 43.45 divided by 3.95 will give us a result of 11. So we pretty much worked this problem out for later on whenever we see it coming up in the text here. We now know that, I think it was Alex was the student's name. Alex bought 11 CDs. So I've pretty much done the same thing, right? I subtracted first right here, and then I divided. So same concept, just a little bit different way of looking at it. So here in example 1, it says solve two-step equations. Solve 10 equals 6 minus 2x and check your answer. So notice at first, x is multiplied by negative 2 and then 6 is added, right? And so now we're going to work backwards from both sides. And that means that we want to first deal with this 6 right here. So 6, this is a positive 6, right? It doesn't have a plus sign in front of it, but we do realize it's positive. So to get rid of the 6, we need a negative 6. What we do to one side, we're going to do to the other. The 6's are going to cancel each other, and 10 minus 6 is 4. And let's bring down this negative 2x right here. We now have 4 equals negative 2x. The x is being multiplied times negative 2, so let's use the opposite operation of division. Every fraction's a division problem. We're going to divide by the very number we wish to get rid of, and that is this negative 2 that is out here in front of the value of x. So we're going to divide by negative 2, and what we do to one side over here, we're going to do to this side over here as well. The negative 2's are going to cancel each other out, leaving us with just x, and they went ahead and written 1x here, so you realize that that 1 is there. And 4 divided by negative 2 is negative 2, and now 1 times x is x, therefore x equals negative 2. And go ahead and plug that into your original problem up here for checking it. So wherever x is, we're going to plug in negative 2. So we would have negative 2 times negative 2. Oh, they're doing it another way. 2 times negative 2 is negative 4. They bring down the subtraction sign. 6 minus a negative 4 is a positive 10. I would have done this a little. I would have looked at this as negative 2 times negative 2 is positive 4, and 6 plus 4 would be 10. Same difference. Let's go ahead and look at, let's do 1c. That one looks interesting. So n over 7, and add that to 2, and that should equal 2, and we want to know what is the value of n. So for this one here, well, before we can get to this n over 7, we need to deal with the negative 2 that's right here, or the positive 2 that's right there. So let's go ahead and subtract 2, and what we do to one side, we're going to do to the other. And this one should be interesting. Oh, no, yeah, we should be good to go. I see what it's going to be. So with that said, the 2 minus 2 is going to give me 0. This is where it was starting to get interesting. The 2's are going to cancel each other out, leaving me with n over 7. Yeah, that's still going to be, Yep, I see. Yep, makes very good sense. I'm looking down at the problem already. So now the n is tied to the negative 7 here through division. We want to multiply by the very number we wish to get rid of, which is 7. Or another way to look at this is we're getting rid of the fraction by multiplying times the denominator. What we do to one side, we're going to do to the other. 7's cancel each other, leave me with just the n, and 0 times 7 is 0. You might be thinking, 0? Does that make sense? Well, let's go ahead and put that in. If I put a 0 in here, right? 0 divided by 7 is 0. Bring down the plus 2 equals 2. 0 plus 2 is 2. And 2 equals 2. So indeed it is. I'm going to go back and do 1a. Just mainly because I don't want to finish this example off with something that ends in 0. So negative 4. And I'm going to add to that plus 7x equals 3. And so before we deal with the 7 that's tied to the x, we have to deal with the negative 4 here. The opposite of negative 4 is positive 4, so let's add 4 because we want those to cancel each other out. What we do to one side, we're going to do to the other. The 4's cancel each other, leave me with just 7x on the left. and 3 plus 7 is 10. Oh, I gave the answer. That wasn't right. See what I did there? I need to add 4, and it equals 7. There we go. Now, 7 is tied to the x through multiplication. We're going to use division. Divide by the very number we wish to get rid of, which is 7. What we do to one side, we're going to do to the other. 7's cancel each other, leave me with just the x. 7 over 7 equals 1, x equals 1. Let's go ahead and plug that in. 1. So 7 times 1 is 7. Bring down the negative 4 and the plus sign. Equals 3. Negative 4 plus 7. Well, this is adding integers, right? One's positive, the other's negative, so let's go ahead and actually subtract. The difference of 7 and 4 is 3. 7 has a greater absolute value than negative 4, so since 7's positive, our answer is positive. Bring down the equals 3. That's a true statement, and our answer checks out. Example 2, solving two-step equations that contain fractions. So we have q over 15 minus 1 over 5 equals 3 over 5. So method 1 is to go ahead and use fraction operations. So since 1/5 is subtracted from the q over 15, we're going to go ahead and add 1/5 to each side. So let's add 1/5 to each side. Done that. And here, negative 1/5 and a positive 1/5 is going to have a total of 0. Means they're just going to cancel each other out. And we're just going to get q over 15 on the left side of the equation. 3/5 plus 3/5 plus 1/5 is 4/5. My brain's getting ahead of me wanting to do the answers today. Now I would have q over 15 equals 4 over 5. Best way to get rid of a fraction, multiply by the denominator. So let's multiply by the denominator of 15. And what we do to one side, we're going to do to the other. So the 15's cancel each other, giving us q. 15 times 4 over 5 is the same as 15 times 4 over 5. 15 times 4 is 60. 60 divided by 5 is 12. Therefore, q equals 12. Now, there's another way to do this. And you'll see that this is, as I change the slides here, is what I'm saying. It's all tongue-tied today. Whenever I change the slides, you'll see that this is the exact same problem that we're going to do here. And we'll come up with the answer of 12 again. So let's look at the other method. Method 2 is to multiply by the least common denominator to clear the fractions. And the least common denominator is going to be the least common multiple of all the denominators. So if we consider 15, 5, and 5, least common multiple is going to be 15. So we're going to multiply both sides by 15. So let's take this q over 15 minus 1/5, put that in parentheses, and then multiply times 15. And then take the 3/5 and put it in parentheses and multiply by 15 as well. We've now multiplied both sides by 15, which is the least common denominator, which is also the least common multiple of those denominators. And let's go ahead and distribute that 15 in to both sides. So 15 times q over 15, and 15 times 1/5, and the minus sign they put out here in front of the 15. Now, let's deal, and we just bring down this 15 times 3/5 there. Let's go ahead and deal with the 15 times q over 15. Well, that's just going to be q. The 15s would cancel each other, leaving us with q. And then we would have, they bring the minus sign down. I would have done this a little differently, but they would go ahead and bring the subtraction sign down. 15 times 1 is 15, divided by 5 is 3. 15 times 3 is 45, divided by 5 is 9, so we get q minus 3 equals 9. Now we have a one-step equation. Negative 3, let's add positive 3. What we do to one side, we do to the other. The 3's cancel each other, leaving us q, and 9 plus 3 is 12, so we would get 12 once again. Let's see, let's try example 1. Let's try one method with one with the other. So let's go ahead and do the 2x over 5, and we're going to subtract 1/2 from that, and that's going to equal 5. Now, since we're dealing with fractions, I'm going to go ahead and write this 5 as 5 over 1, right? We can change any number to a fraction by just putting it over 1. So let's go ahead and deal with the negative 1/2. Let's go ahead and add 1/2 to it, right? So what we do to one side, we're going to do to the other 1/2. 1/2 cancel each other out, leaving us with 2x over 5. And then next thing we want to do is go ahead equals, and then 5 over 1 plus 1/2. Well, let's do that off to the side. 5 over 1 plus 1/2. Well, let's write equivalent fractions here. So I want denominators. I want like fractions is what I'm saying. So if the denominator were 2, that would work. Here the second one's still going to be 1. But if I multiply 1 times 2 to get 2, then 5 times 2 is going to be 10. So 10 over 2 is the same as 5 over 1. Now I can go ahead and do 11 over 2, right? 10 plus 1 is 11. So that's going to be 11 over 2. Now I need to multiply both sides by the denominator. So let's go ahead and put these in parentheses. We're going to multiply both sides times 5. And whenever we do that, the 5's cancel each other, leave me with just 2x on the left. And 11 times 5 is 55 over 2. Now I would want to divide by 2. That's not going to work out very friendly, is it? So I could write this as, I'm going to go ahead and do a rewrite here. 2x divided by 2. And then on the right, I'm going to write it differently. And there's a reason for that. 55 over 2 divided by 2. And I'm going to write 2 as a fraction of 2 over 1. Now that I have fraction division, now I'm going to take this portion right here and I'm going to work it over there on the other side of the screen up here. So 55 over 2 probably would have been better to use the other method on this. Divided by 1/2. So we're going to use keep, flip, change. We're going to keep the first fraction. We're going to flip the second. And that's going to become 1 over 2. And we're going to change the multiplication times. 55 times 1 is 55. And then 2 times 2 is 4. Now we would end up with the 2's over here canceling each other. We end up with x equals 55 over 4. And then from that point, we could simplify that. 4 goes into 55. 10, 11, 12, 13. Check. 13 times 4 equals 52. Yep. So x would equal 13. 52 remainder of 3 over 4. 13 and 3/4. And I'm not going to plug that in and check it. I feel pretty confident about my work there, but I'm not going to plug that in and check that one. Second method, let's go ahead and clear all the right over here. Erase. And let's try the second method out. Use that. On 1/5 n, I'm doing the last one down here, 2c, minus 1 over 3 equals 8 over 3. So what's the least common denominator, or the least common multiple? 5, 3, and 3. That's going to be 15, right? So I want to go ahead and take this 1 over 5n minus 1 over 3 and put it in parentheses equals 8 over 3. Let's put it in parentheses as well, and we're going to multiply both sides by 15. So here I have 15 over, or distribute the 15 into the, I get 15 over 5, right? Don't forget the n. And this is a positive times a negative, so I'm going to get a negative. And 15 times 1 is 15 over 3 equals, now I'm going to go ahead and do, I really wish I should do some canceling here on that. This is how I look at it. Let's see. And I think I'm going to. Let me show you what I'm talking about here. 3 times 15. I'm going to write this as a fraction. I want to show you what I'm doing in my head. So 3 divided by 3 is 1. 15 divided by 3 is 5. Now I can do 8 times 5 is 40 over 1, and that would equal 40. So the right side is going to equal 40 over here. Now I could do some more simplifying here. 15 divided by 5 is 3. Take the n. Minus 15 divided by 3 is 5 equals 40. Now this is a little bit simpler, right? So let's go ahead and add 5. What we do to one side, we're going to do to the other. 5's will cancel each other. 3n equals 40 plus 5 is 45. And then now let's divide both sides by 3. 3's will cancel. We get n, and 45 divided by 3 is 15. A little bit easier that way. I kind of like the second method better than I do dealing with all the fractions on the first method. All right, moving along. Equations that are more complicated may have to be simplified before they can be solved. You may have to use distributive property or combine like terms before you begin using inverse operations. So example 3, simplify before solving equations. So we have to simplify this, and we have 6x plus 3 minus 8x equals 13. So we do the rewrite here, and notice that we have 6x's and a negative 8x's. So using the commutative property, we're going to switch the negative 8x with the positive 3. We see that's done right here. Now we have our x's next to each other, and we can combine those terms. So 6 minus 8 is negative 2. Negative 2 what? Negative 2 x's. Let's bring down the negative 3, bring down the 13. Now let's deal with the positive 3 by subtracting 3. What we do to one side, we do to the other. 3's cancel each other, leaving us with just negative 2x on the left. 13 minus 3 is 10. We now have negative 2x equals 10. Let's divide by the very number we wish to get rid of. So we want to get rid of this negative 2. So we're going to divide both sides by negative 2. Negative 2 divided by negative 2 is positive 1. 1 times x is just x, so the negative 2's cancel each other. And 10 divided by negative 2, that's positive divided by negative, so the answer is going to be negative. And 10 divided by 2 is 5, so we see our solution would be x equals negative 5. Now you might also have to distribute before you simplify or you solve. So helpful hint over here, you can think of an opposite sign as a coefficient of negative 1. So up here we're going to see this minus the quantity of x plus 2. Think of that minus the quantity of x plus 2 as negative 1 times the quantity of x plus 2. So you can kind of picture a negative 1 being squeezed right in the front of that right there, if you want to look at it that way. So let's see what they do here. We're going to keep bringing down the 9 all the way on the left for a while. We're going to rewrite this minus negative 1. We're going to squeeze that negative 1 in there. And what they're doing is we're going to write subtraction as the addition of an opposite. So they take the subtraction sign, turn it to addition sign, and then take the opposite, and they go ahead and throw the negative in there. I would have just thought of this as plus and negative 1, which is exactly what they did, plus negative 1. So we distribute the negative 1 into the quantity of x plus 2, negative 1 times x here, negative 1 times positive 2 there, so distribute that in on both those. Let's go ahead and solve this. Negative 1 times x is negative x. And again, they've changed the sign and then took the opposite there. And then we also have the negative 1 times 2 is negative 2. And again, they've just switched out and they're adding the opposites here. Then we would use the commutative property, get the negative 2 over by the 6, and then move the negative x over, so the negative x goes to the right, the negative 2 comes to the left. Now the 6 and the negative 2 are next to each other. We can go ahead and combine those terms. 6 minus 2 is 4. Bring down the negative x. Now we have a positive 4. Let's get rid of it with the negative 4. What we do to one side, we do to the other. The 4's cancel each other, leaving it with negative x. And 9 minus 4 is 5. So we have 5 equals negative x, but we can't have a negative as our solution. We need this to be a positive x. So let's go ahead and divide by negative 1. And what we do to one side, we do to the other. Negative divided by negative is positive. X divided by 1 is x. 5 divided by negative 1 is negative 5. Now, I kind of like to think of this line right here. I'm going to rewrite that over here. 5 equals negative x. Textbooks will always tell you divide by negative 1. Well, I kind of like to think of it as multiplying times -1. So if I multiply both sides times -1, I'm still going to come up with the same result. I'm still going to get -5 equals positive x, either way. So I prefer to think of it as multiplying by -1. Textbooks will always teach you to divide by. And technically, they're right, I suppose, because that is a -1 being multiplied by x in the inverse operations division. So you could definitely look at it that way. Let's go ahead and we're at 25 minutes. Do I really want to go ahead and, yeah, I think I will. I'll do one. Let's do, where do I want to squeeze it in at? Let's do 2a plus 3 equals, oh, not equals yet. I have a minus 8a equals 8. So I'm not really going to bother with writing a separate line for the commutative properties and switching things around. I'm just going to see, oh, I have 2a's here and a -8a here. So let's add 2 plus -8 is going to be -6. -6 what? -6a. I still have the positive 3. Let's go ahead and bring that down and bring down the 8. Now I need to get rid of this positive 3 with a -3. What I do to one side, I do to the other. These 3's will cancel, and that leaves me on the left with a -6a equals, and 8 minus 3 is 5. Now I need to go ahead and let me double check. I'm double checking my work. 2, -6, yep, bring down the 3, subtract 3, 8 minus 3 indeed is 5. Okay, because it's going to be a fraction. I was thinking it'd be something a little bit nicer. And now I need to go ahead and divide by -6. What I do to one side, I do to the other. And the -6's cancel each other out, leave me with a. And I end up with, I'm going to go ahead and put my negative with the numerator. I like it better that way. So -5/6, and that would be my answer. So let's look at problem solving application real quick. We'll kind of run through this real quick, because we pretty much solved this earlier at the beginning. So in example 4, remember Alex belongs to a music club. In this club, you can buy a discount card for $19.95. This card allows you to buy CDs for $3.95 each. After 1 year, Alex has spent $63.40. Write and solve an equation to find out how many CDs Alex bought during the year. First, we need to understand the problem. Well, the answer is going to be the number of CDs that Alex bought that year. So we know that whenever we get done, that should be the solution. That number is going to represent the number of CDs that she bought. We have some important information here. The discount card itself costs $19.95. Each CD is $3.95. And we know that after 1 year, she has spent $63.40. So how would we set that up? Well, our total cost is going to be equal to the cost of the compact disc plus the cost of the discount card. So we know that each CD, the total cost of the CDs is going to be $3.95 times C, because each one of them is $3.95. Every time we buy one, it's repeated addition, which is multiplication. So we need to multiply by however many CDs she got. So let's take the total cost that we know, which is a $63.40. The cost of the compact disc was $3.95, so that's $3.95 times C. And the cost of the discount card is $19.95. And then example 3, step 3 here is to solve. We did that at the beginning of the video whenever we talked about my personal way of doing it. And we got down to, indeed, we had the answer correct. It is 11 CDs. If we look back, we can check, is this answer reasonable? Well, the cost of each CDs is about $4. And if we're saying, okay, she bought 11 of them, that means she spent roughly about $44 on the CDs. The cost of the discount card was pretty close to $20. So we take 44 plus 20, we would get 64. Well, 64 is pretty doggone close to $63.40. Therefore, our answer of 11 does indeed make sense. Next, we have example 5, solving equations to find an indicated value. And on this one here, the idea is if 3a plus 12 equals 30, then find the value of a plus 40. Well, that makes sense. We're going to have to use the first equation to find the value of a. Then we're going to have to substitute that value into the second expression here of a plus 4. So first find the value of a. Well, plus 12, let's do a negative 12. What we do to one side, do to the other. 12's cancel each other, leaving us with 3a. 30 minus 12 is 18. We now have 3a equals 18. The 3 is tied to the a through multiplication. The opposite operation is division. Every fraction is a division problem. We want to divide by the very number we wish to get rid of, which is 3. What we do to one side, we do to the other. The 3's cancel each other, leaving us with just a. 18 divided by 3 is 6. So we now know that a equals 6. Step 2 is find the value of a plus 4. So let's substitute in 6 for a. 6 plus 4 is 10. That brings us to guided practice. I'm about 30 minutes in on this one, so I think we did quite a bit of discussions about it earlier. So I don't think I'm going to spend any time on guided practice here. I suppose. See, let's do a fraction one, just for fun. Let's do a fraction one. Let's do number 9 right here. So if we have 2 over 7j, and we're going to subtract 1 over 7, and we're going to set that equal to 3 over 14. Let's try that second method of the least common denominator. So what is the least common multiple? 7, 7, and 14. Well, hopefully you're saying it's 14. So we're going to multiply both sides by 14. Let's put this in the parentheses here. 2 over 7j minus 1 over 7. And then we'll put the 3 over 14 in parentheses and multiply it times 14 as well. So in this one here, I'm thinking 14 times 2 over 7. Well, that is 14 over 1 times 2 over 7. 14 divided by 7 is 2. 7 divided by 7 is 1. 2 times 2 is 4. 1 times 1 is 1. 4 over 1 equals 4. So that's going to be 4. And don't forget the j. Now I have 14 times negative 1 over 7. Well, that's a positive times a negative, so the answer is going to be negative. And I have 14 over 1 times 1 over 7. 7 divided by 7 is 1. 14 divided by 7 is 2. 2 times 1 is 2. 1 times 1 is 1. 2 over 1 equals 2. So this is going to be 2 here. On this one here, 3 over 14 times 14. Well, think of this as 14 over 1. 14's cancel each other. We end up with 3 times 1 is 1. 1 times 1 is 1. 3 over 1 is 3. And we have that. Now we have a two-step equation here. We simply got rid of the fractions by multiplying by the least common denominator. Now we can go ahead and add 2 to each side. Negative 2 cancels the positive 2. And we end up with just 4j. And then we have 3 plus 2 equals 5. Now let's go ahead and divide by 4. And the 4's cancel each other, leaving us with j. And j equals 5 over 4. All right, so that is all of the instruction that I have for Chapter 2, Lesson 3, solving two-step and multi-step equations. Thank you.